So in this triad exercise, we're given the function f of x equals 3x squared minus 2x plus 1, and we're asked to evaluate at specific values of x. So literally all we do is just substitute whatever value we're given for x into the function and then simplify. So f of 3, we have f of 3 equals 3 times, and I would suggest always wrapping your substitutions in parentheses so you don't lose any negative signs if nothing else. So we substitute 3 for x, so 3 times 3 squared minus 2 times 3 plus 1. So that's 3 times 3 squared is 9, minus 2 times 3 is 6, plus 1. So that's 27 minus 6 plus 1. 27 minus 6 is 21, plus 1 equals 22. So f of 3 is 22. A simple way that you could check this would be to graph the quadratic, verify that at x equals 3, the output, the value of the function actually is on the graph, y equals 22. So with part B, we're given f of negative 1. Here's an example of the importance of wrapping substitutions in parentheses. So f of negative 1 equals 3 times negative 1 squared minus 2 times negative 1 plus 1. So 3 times negative 1 squared is just going to be 1. Negative times a negative. So if you change this to plus negative 2 times negative 1, that's going to be plus 2. Or you could rewrite it out the step minus 2 times negative 1 is negative 2, but then minus negative 2 becomes plus 2. And then we're still left with plus 1. So 3 times 1 is 3, plus 2 is 5, plus 1 is 6. So f of negative 1 equals 6. Over here, f of 3 equals 22. And then last but not least, we have f of t. Same process, we just substitute whatever is inside the parentheses. In this case, it's just the variable. So if we have f of x equals 3x squared minus 2x plus 1, then f of t equals 3t squared minus 2t plus 1. We're quite literally just replacing x with t because t is all that we're given inside the parentheses. If it was f of t plus 1 or something to that effect, we would substitute t plus 1 and then simplify by combining like terms. So again, evaluating a function at a specific value of x, simply substitute the value into the function for x and then simplify. And again, I suggest wrapping substitutions in parentheses, if nothing else, so you don't lose any negative signs. For instance, if we had 3 times negative 1 squared here and you squared 1 but kept the negative, then the answer would be wrong. When we square the negative, it becomes a positive. So again, it's important to wrap substitutions in parentheses when you are evaluating a function at a specific value of x.